Hi, I'm Alia and will be present about the origin, prevention, control and treatment of microplastic. Microplastic is a term used to describe small plastic particles that are less than 5 mm in size that can be found everywhere from the depth of our ocean to the air we breathe. They come from various sources. Primary microplastic are intentionally made, like plastic pellets used in manufacturing, and microbeads found in personal care products. Secondary microplastic are formed when larger plastic items like bottles and packaging degrade using photodegradation and fragment over time. They come from sources like synthetic textile, household plastic waste, hospital things such as wipes and tire weathering. Next, microplastic are more toxic due to their small size and are present everywhere in land, water, and air. First, microplastic are present everywhere in land environment. Exposure to sunlight, heat, and mechanical force release smaller microplastic particles into the soil and terrestrial habitat, with plastic mulches and fertilizer used in agriculture contributing to soil contamination. Next, microplastic can be found in water bodies from both primary and secondary source. It is consumed by smaller organisms and make their way up the food chain to concentrate on the larger, longer living organism. Lastly, microplastic also found in the air, posing a widespread contamination issue. Underneath textile, atmospheric deposition from surface runoff and wine-borne particles contribute to airborne microplastic pollution, which can be inhaled and potentially harm human health. Next, we move on to the prevention of microplastic. Microplastic pose a significant threat to our environment, but there are ways we can prevent their damage. The first step is to reduce the production and consumption of plastic. We can achieve this by implementing laws to limit single-use plastic, promoting eco-friendly alternatives, and encouraging sustainable living. We can also practice the 3R concept: reduce, reuse, and recycle. By using the reusable packaging, refillable containers, and embracing recycling, we can minimize waste and decrease microplastic pollution. Other than that, improving waste management is crucial. We need efficient recycling programs that encourage proper segregation and sorting of waste materials, as well as cutting-edge waste treatment technologies by collaborating with researchers and industry experts for technological advancement. These measures help prevent plastic waste from entering water bodies and degrading into microplastic by enhancing waste management and infrastructure. Filtration and treatment technology is also one of the microplastic prevention. We can achieve this by utilizing advanced filtration systems to capture and remove microplastic from wastewater, as well as implement UV light treatment to break down and neutralize microplastic particles. We can also employ membrane filtration techniques to separate microplastic from wastewater and utilize activated carbon adsorption to trap and remove microplastic particles. Lastly, industries must adopt eco-friendly production methods, prioritize biodegradable and compostable products by encouraging the use of alternatives to traditional plastic to minimize microplastic pollution and reduce the escape of microplastic during production. Microplastic pollution is a growing concern for our environment, but we have strategies to control and treat this problem. One way is through engineering tools like wastewater treatment plants. These plants have shown high clearance rates ranging from 90% to 98%, while the techniques such as electrodeposition and membrane bioreactors have achieved remarkable results with a removal rate of 99.4%. Promoting the use of bio-based and biodegradable materials is another key strategy, where plastic made from renewable resources provide alternative to traditional plastic. Biodegradable plastic can naturally decomposition, reducing their impact on the environment. Lastly, bioengineering offers a promising solution. By harnessing the power of bacteria, fungi, and enzymes, we can biodegrade microplastic. Some microorganisms and enzymes have already demonstrated the ability to break down specific polymers like PET and PE. With these control and treatment strategies, we can combat microplastic pollution. Last but not least, together let's take action to protect our environment from microplastic pollution. That's all from me. Thank you.